Okay, year 10 and 11s, we're looking at differentiation. We're continuing our work in there. And number 5, we've been given an equation here. It's a cubic, and we've got a couple of unknowns, an a and a b. They're constants, but we do know one thing. We know there's a stationary point here, and we've got to find the value of a and b. So my first step is, well, let's differentiate, because I know that a stationary point has a gradient of 0, so that's probably going to help me. So if I differentiate, that first bit becomes 3x squared. The second bit becomes 2ax, right? 2 times the a, the x drops down a power, and the b disappears out. Now, since there is a stationary point, and we know where it is, the stationary point has a gradient of 0, and we know that it's at x is equal to 4. So let's chuck in that 4 there. So 4 squared there, plus 2 times 4 is 8, so it's 8a equals 0. So 3 times 16 is 48, is equal to negative 8a, and so a is equal to negative 6. Now we know what a is, we can chuck it back into the initial formula. This is our initial formula. It's going to be, not plus now, is it? It's going to be minus 6x squared, because a is minus 6, plus b. Now let's insert these points in. So minus 27 is equal to 4 cubed minus 6 times 4 squared plus b. Whoops, plus b. Now, bring everything across to one side. So I've got minus 27. Now 4 cubed is 64, so minus 64. And then we go plus 6 times 16, which is 96. And that gives me b is equal to 5. Okay, perfect. So we now know that y is equal to x cubed minus 6x squared plus 5. Okay, the nature of the stationary curve, stationary point, sorry. So for part B, I'm going to do the second derivative, and that means I'm going to differentiate this, and it should give me 6x plus, and then 2a x. So the x drops out, it's just going to be 2 times a, and we found that a was negative 6, so it should be minus 12. So in actual fact, let's just get rid of that and go minus 12. I think that's what we're going to have for the second derivative. Now that I know that, I'm able to find the coordinates of the other stationary points on the curve and determine the nature of the stationary point. Okay. I've got a... No, sorry, I've jumped the gun. For part B, I also need to find the nature of the stationary curve at here. So at x equals 4, the second derivative is equal to, now we go, 6 times 4 is 24, 24 minus 12, it's 12, and therefore we have a minimum point, because we learnt that when the second derivative is greater than 0, we have a minimum point. Okay, that's something you need to start memorizing, year 11s. Okay, now the last step here is to find the coordinates of the other stationary point. Okay. Right. So we go find out the stationary point. We've got 3x squared minus 12x is equal to 0. So we can divide that by 3. Now, if we factorize this, we can see that we've got a stationary point at x equals 0, and, whoops, that's a 0, and x equals 4. Now, we've already done this one, so we want to now do this one here. So, again, what kind of result do we get when we chuck this into our second derivative equation? We're going to get 6 times 0, so I'm chucking it in here. 6 times 0 is 0 minus 12. So we're going to get minus 12. And therefore, since it's less than 0, we know that we have a max point, a maximum point. Okay, to find the coordinate, I'm just going to chuck this 0 into this equation here. So the coordinates would be 0, 5. Okay, well, I hope that helps you guys. Good luck.